Hi, in the next presentation I will talk about my works. My first robot was Kian 4. I took the idea of puppets, where the motor was the one who pulled string, and multiple switches commanded the engines. Thus, I was able to build a robot with 10 degrees freedom, with ability to move its arm, forearms, open and close its thumbs, turn its head, move and rotate half a body, 90 degrees through a counterweight. The robot was not perfect, but it was a symbol of perseverance that will encourage me to follow the robot line for the next few years, especially by developing low-cost robots. In 2015, the marketing teams of the institute where I worked as a teacher was looking for a way to attract new entrants, so I proposed the Asimov project as a host robot, accepted the assignment, formed a work group with the students, and began its construction, which lasted about 3 months. The result was that Asimov could move his arm, turn his head as if saying no and as if saying yes, in addition using speech recognition. Asimov could be asked a question and he will respond. Here is an example of how Asimov answers a question.
El proyecto Iberotec representa un compromiso estratégico asumido en el marco del Gran Proyecto Iberoamericano Metas Educativas 2021.
A television program called The Great Idea invited my company to participate in the project competition, so we are preparing to join to achieve more visibility as a company focused on robotics and putting the construction of robots to the test in short period. In the context, we featured LIRMM, a tourist robot, and Tombobot, a Polish robot. With RoboHair, the tourist press any option on the screen to receive information in spoken form.
Poder indicar los principales lugares turísticos de la zona, tales como restaurantes, museos, lugares históricos, entre otros.
And keep some object in the safe locker that the robot had. In the case of Tombobot, upon receiving an alert signal issued by the alteration of the user-guided pulse, it immediately turned on its light and sound alarm. It went to the user location to assist them. Furthermore, the robot sent a video transmission in real time and its GPS location by TCP/IP to the mobile application. I had a high participation in all this project, with Asimov in 2015, the robot Hair in 2019, and Tombobot 2 in 2019. The three robots are based on a structure made of aluminum. The controller is Arduino, and the movements are controlled through a mobile application developed in the Inventor app, where, for example, the robot's action can be controlled. In the specific case of robot Asimov, the command by touchscreen button, move each arm, will control rotation head, command by speech recognition, the robot can dance and pre-programming response. And of course, with the robot controller Arduino, 2 servos for arms and 2 servos for move the head. In the case of RoboHair, you can control the wheels and you have a specific operation system in Android using a Raspberry Pi. I developed a mobile application with App Inventor, command by touchscreen button, for option to speech, for give information to tourists. In the case of Tombobot, it's very similar. By command by touchscreen button, control the wheels, turn on off the lights and the sound alarm, but you have a camera and GPS for send the TCP/IP information. Between 2019 and 2021, I carried out the ROBS project Wirabot, RUB and HiCam, the latter two being focused on the context of the pandemic. In the logistics sector, companies are interested in a system that will be in charge of storing and taking the product from the shelf, where the type of product could be hundreds or thousands. So the Wirabot project was conceived as an opportunity in the market. The construction of Wirabot was based on the three fundamental characteristics. The material and device used should be readily available in the local market to provide immediate support. The material should be solid and durable focus for an industrial environment. Material and device had to be as economical as possible to make the project attractive to clients. Wirabot is a 1.95 meters humanoid robot made of stainless steel material with 6 servo motors, 3 in each arm, adapted from DC motors made by me, where transmission bells. A person can interact with Wirabot in a spoken way, since the Google Cloud SDK has been used for natural language processing (NLP). You will see an example.
Puedes buscar la fanpage de Robotics Lab y podrás enterarte de mis novedades.
When the quarantine was given in Peru in February 2020, all the stores were closed. No one could leave their home except to buy food, so I thought if there was a way with my knowledge and the materials and device that I had could help against COVID. So researching I found the benefit of type C ultraviolet light. UVC lamps were used in China and Italy during the pandemic in clinics and hospitals. The principle of disinfection is simple, where the lights fall according to the time, distance, and power of the lamp utilizing a radiometric calculation. Inactivation of COVID-19 can be guaranteed. The main feature of ROV is its turning and lifting mechanism that I designed with the inventor software for adaptation to a square aluminum tube that served as a support for the lamps, and its turning mechanisms that allow 360 disinfection, which I have a utility model patent regarding this mechanism. ROV was able to perform the disinfection for free at a police station in the area. The intention of helping selfless during the pandemic made the International Ultraviolet Association offer me membership in their organization for 1 year without payment. Similar to the other projects, I use a mobile application developed in App Inventor for controller, the Arduino. In the case of wearable robot and the ROV, I use a RS485 communication because it's very useful for long cable. In the case of wearable, I use a web server Google Cloud SDK PHP. First, the microphone, I receive the sound, I use the WebKit Speech Recognition API, then I send a query to Google Cloud Natural Language Processing NLP, then search in the database and give me a response. So with this response, I use a third-party voice API for the robot get a spoken response. For ROV, I use a manual mode and automatic mode. For automatic mode, the sensor that I use is an ultrasonic sensor, and I use a second controller for move the CX rotation and motor for lifting. One of the requirements to minimize contagion is social distancing. So doing a market study saw an opportunity to use delivery robots. For this, we had to mentorship of Silicon Valley Robotics, taking the project from TRL1 to TRL6. TRL meaning Technology Readiness Level, and 6 meaning Prototype Demonstration in a Natural Environment. The robot has a rocky-bocky suspension that allows it to pass over uneven terrains. In addition, the upper part of the robot chassis can be separated for easy transport. I developed a second version of the robot delivery using relay and ESC. It was a cheap way for control a bruised motor. My participation developed Wirabot in mechanical was 95%. So about controller programming, mobile application 100%. About ROV and Haika, it was 100% in mechanical controller programming and mobile application. In total, I have 3 patents: Brazil 2016, Smart Card Reader in 2018, and the patent process ROV in 2020. The Smart Card Reader is used to extract digital certificates, whether authentication or signing, and smart card. In the case of Peru, it's used to sign digital documents using electronic identification. There are other smart card readers on the market. The patent is based on the electronic distribution and the housing design that allowing optimizing its use by placing the card on the back compared to the other model placed on the side, not allowing nearby USB ports. My participation in the electronic design was 60% using the software Eagle and the design of the case using the software Inventor 100%. I should mention as an achievement that my smart card reader is listed on the government website as a recommended distributor. Brazil is a device that will allow people with disabilities or without disabilities to receive the same information in the same way through electrical pulse distributed in a specific pattern. First, you save the information in audio format. It is in a DTMF codification. It sounds like this. The Arduino controller uses the decoded DTMF and sends it by Bluetooth. The other Arduino, like a receiver, shows this information in a display and transforms the signal to electrical pulse and use the matrix of electrodes. My participation in mechanical control and mobile application was 100%. Okay, I will summarize my skill. I know programming with Visual C++, C#, Python, I taught a basic course with Python in the university using Visual C++. I use Java with Android Studio and Eclipse. In my master thesis, I used Java, Rust, and Protocol YARP because the master thesis was about to develop like a touch pedal because the robot Tio didn't have a touch pedal for control the movement or visualize the information. So my work was about develop this app application. I used the Microsoft Robotic Developer Studio for my degree thesis. In my degree thesis, I simulate a robot SCADA with 4 degrees of freedom. I used a backpropagation for part selection process. I used to SCADA developed in LabVIEW. In LabVIEW, you will see the simulate camera and the real-time training of the backpropagation. I have 2 certifications with programming robots with KUKA, Programming Robot 1, Programming Robot 2. I learned it in KUKA College in Barcelona. I know Programming Robot ABB. You will see now an example of simulate of a process with quad robot. I used this simulation for my master course, and it is a little complex simulation with several robots. This process, you will see that ABB like it because they give a comment in my channel in YouTube, so they like my video programming with Robot Studio. I know General Robot Fish Panel language because I made implementation the last year in 2020 in metal mechanical industry. So it was a welding robot. I programming this robot. I know to Arduino because you see all my last video was programming with Arduino. I know basic MATLAB for simulation and LabVIEW. About CAD, I know Inventor and SolidWorks, but more often use Inventor. I know Eagle, Design PCB Basic. For example, I use it for the smart card reader, for the electronic design, and AutoCAD. I know HTML, JavaScript, jQuery, 3GS. For 3 years, I developed a virtual environment last year. I used for this project the WebGL. WebGL is when you want to import some 3D objects and use the CSS3D is when you want to import, for example, video streaming or maybe a web page inside this virtual environment. The great characteristic of this virtual environment is a web browser and takes seconds. It's not necessary to install nothing. I simulate the collision of the object, the reflection, refraction. You will see the water, for example. I use Socket.io for multiplier characters and the animation of different characters. Last year, I saw an opportunity to develop the platform for virtual events. I did some tests with the Lima Chamber of Commerce in Peru. They like it, but some tests are still missing, such as connecting multiple users simultaneously. I used operating system Windows Server 2016, all the versions of Windows, Linux, Principal, Ubuntu, and Android. To finalize my presentation, I would like to comment on my current position. I am the current chair of the IEEE RAS Peru. This event will be taken from the August 6 to 8. This object was to convene a large number of students, create a research group to obtain different types of low-cost humanoid robots, then make them open source to achieve the largest participation on contestants. I called for 200 electronics and mechatronic engineering students from Peru, where obtained 4 types of mini-humanoids. I supervised 4 types of mini-humanoid robots low-cost projects from April to May. We present for paper, of which 2 were accepted at Intercom 2021. Intercom is an event IEEE which indexing in Scopus. The result of this work has been the participation of 9 universities, 25 teams, and 87 participants. You are observing the 2 main types in mini-humanoid robot. The robot on the left side was made with MDF material. It has a height of 28 cm, 16 microserves, SG90, and 312 grams. The pattern on the wall was made manually, point to point. My participation was 60% in the programming, of the servo with Arduino and the generation of movement. The other 40% correspond to the student that I have supervised who made the design in MDF. They were inspired by the robot of YouTuber Dr. Giro, Masahiko Yamaguchi, who I keep in touch on Facebook. The robot on the right side was made of cardboard. It has a height of 29.2 cm with 20 microserves. SG90. It still does not work, but the goal is to develop a mini-humanoid robot, open source project with a large amount of resources so that robotics enthusiasts have a research platform. Since last year, we have been working on creating a robotics research and development center with my friend Rolando Cruzado. He has a master's degree in Innovation UK and has experience as an accelerator manager CXL in USA. One of our goals for 2022 is to launch an acceleration program in Latam. We have strong partners like IARA, International Alliance of Robotics Association, and ESBR Robotics, Silicon Valley Robotics Industry Association supporting innovation and commercialization of robotics technology. Finally, I would like to mention that I have two communities on Facebook, one called Da Vinci and Tesla, with more than 17,000 members, with the object to share information about science, tech, awareness of our resources and animals, and my other community with more than 6,000 members, called Robotics International Community, aiming to reduce the robot gap in Latin America through international networking. I appreciate the attention and the time given.